So beyond that, without further ado, I'd like to bring up front here the lady that has made all of this possible, who was her dream and her vision and her drive that allowed all of us to be here and to make it through this. So I'd like to bring up Amy to go ahead and run everything.
I want to thank all of you guys for coming and participating. We have planned this for a long time, and it's so exciting. And I want to thank Google. Jonathan, thank you so much. We appreciate all of your support. And Intel was a sponsor as well. So was AWS, iRod, Science Gateways, and Lotus. So we had a lot of people behind us and a lot of companies to help pull this off and support it. But without you guys as participants, this couldn't have happened. So we appreciate everything you guys have done. And we can't wait to see your presentations and all your hard work. So I think it's all going to pay off. And Lloyd, do you want to say anything too?
No, this has been really fun to watch, and it's really enjoyed working with y'all, and hope to keep in touch as time goes on. Thanks for participating.
And should we start? So does anybody want to volunteer to go first? You guys, good. Come on. We have a volunteer to go first.
Okay.
I'm so excited he's volunteering.
All right. All right. Yeah, this is final presentation, guys.
Might have to stand behind it. Yes.
You could stand in front of it and turn the laptop towards you. Like turn it this way? Yes. Yeah, and then,
And that
still
doesn't
right
work.
there.
Actually, go back there, because then the live stream will look at everyone's backside. We can.
And while you all are getting set up, would you mind letting me know which GitHub account are you using? Sean?
Yeah, I
Sean?
can.
Gotcha.
So, as you guys know, we are from Belkin. I mean, our group name is Belkin. I'm Nishan, Ryan, and Bamnat. So, what the main objective of our hack was to create a machine learning model that will predict like the movie ratings. So, the movie ratings like are based on like different categories, like what kind of plot it is, plot, script, performance, cinematography, and the overall movie rating. So, what we're trying to do was get the different ratings of plot, cinematography, and see how they are correlated with the overall ratings. So let's go ahead and see our like chunk of goals. So first goal was to gather a lot of data. For gathering data, we tried to use API from IMDb and Rotten Tomatoes, but that didn't come out so well. We'll talk about it later. The next step was to filter data and to make it into usable form, especially known as like cleaning the data so we can actually use it. And then after that, it was to create a machine learning model which could actually take the data and give us predictions like what's going to happen. And yeah, feed the data, and yeah. And after we get the prediction, we're actually training the machine learning model to by feeding the data which we already have to predict the ones we didn't have. So we used 90 to 10%. The 90% data we used was for the training, and the 10% was for the prediction. And after we got our predictions, we tried to use our linear regression to see like how much our predictions are accurate or it's not accurate. So we got some interesting findings that all the factors like plots and script, performance, cinematography, actor performance, they were like very related to the overall ratings. That means improving on each factors could actually improve on the movie. But since we didn't have a lot of data, we actually had like 5,000 data sets, which is not a lot. So I guess like something different can come upon if you have a lot of data. And the most interesting thing we found was the plot rating. It had the highest correlation. The more the plot rating has the like it's good, the more the overall rating is gonna be good. And yeah, this is 92, and our error percent was 8.75%. After we got the data back from the machine learning and compared to the actual data, we only got 8.75% error. So what we got from this was like, this can help movie makers to predict like if what factors should we take and improve to make the movie better. So they can say, okay, when you have to budget the movie, which factors should we focus most? Is it the plot, is it cinematography, or is it the actors, something like that. So maybe in future, if we have a lot of data and more technology, we can actually start predicting like, okay, only this factor, let's experiment with this and see how the movie comes up and how the ratings are. So this is the data we got.
I can walk them through the data. Like,
Okay.
let's click on Visa Pro. Yes.
So this is our code.
Yeah, as Nishan said, we tried to extract the data from Rotten Tomatoes API, but they required us to get a key from it and stuff. So we kind of circumvented that by actually searching for data that has already been made, somebody who's compiled it, and we instead used that data. So basically what we did was just like parse it into a format that we actually needed it, randomized it so that we can use it for our scikit learning model. We use XGBoost, and basically we made life a lot easier for us. It just gave us the model based on those 4 factors Nishan talked about. So the actual prediction value given, if we can go back to our presentation slide. Yeah, so like the predicted value of like the IMDb rating were these, but the actual rating, our test case, gave us these data. So like, as you can see, it's mostly similar, but obviously the graph, since it's, as Nishant already mentioned, it's 5,000 data sets, it looks perfect. There were small differences, but overall the error difference was approximately just 8%. So that was pretty good. I think we're done.
Yeah, and so we had like some obstacles that were like getting the data from the API, but it was very much harder because most of them wanted us to pay, and we didn't have a lot of time. Next was transferring files to the Google Cloud. We didn't have any experience with clouds, so we got a lot of help from our mentors who were great to help us. We ran into some trouble, but it was troublesome. It was a great experience, and this is we call like the mentor effect. After coming here, before we were like, we didn't have a plan actually, like what to do, but after that, like we actually came up with something to solve. And I want to thank you all from my team, like to helping us achieve something today. Thank you.
Yeah. Any questions?
So I have to ask, because, well, I have to. So how did you find out that there was only about an 8% difference? Did you do any type of statistical analysis?
Yes, we actually used a linear regression. For the modeling, we used linear regression to do the fit. But for the 8%, we actually compared each of the data set, the actual data set and the predicted data set, like did a percent difference basically. And then like averaged it off for every data set, and that gave us like the percent error difference, and that came about 8%. And yeah, as Nishant already mentioned, some factors played. So the plot contributed more to the rating. The way we figured that out was using a linear regression model, and we compared the chi-squared values, and for that the chi-squared value was like significantly less than the other, say cinematography or like script. So this tells movie producers basically, so it gives them a hint on which side of the movie they should focus on. So per our data plot, if they focus more on the plot, I think it would contribute more for the overall rating. Yes.
So what models did you guys use? You said you used linear regression to try like other models?
No, we just used linear regression. Took us a little while to get head wrapped around it, like the chi-squared.
Yeah.
Like we use linear regression to compare what our prediction and for the test case, like the prediction. What we used was scikit learning, like SKL.
Stutter and XGBoost for those.
So it's edibles?
Yes.
Yeah, to get like the predicted values, we had scikit basically come up with like the machine learning stuff, and then we compared that predicted value, the actual value, did a linear fit model, and then like as you saw, So it's like perfectly linear, basically.
Good job.
Thanks.
All right. Who wants to volunteer / be voluntold next? Any volunteers? They're discussing. I'm gonna start thinking of a number between 1 and 3. All right. So right now, this is Team Chaos. Chaos.
Just turn down your volume.
See, now they have everybody's attention.
The digital nails in the.
That's right.
Present.
Top right, other side. Here, here.
Yeah.
Okay. My name is Samuel Testament, and my teammate right here, his name is Nathan Weeks, and our group name is Team Chaos, but now we changed it to Team Order because everything has come to order.
I like that.
So the whole project is focusing on red flower beetle, and I mean the whole abstract of the project is we are like I said yesterday, we're gonna use I'm sorry, we're gonna use a software known as Canoe, and use the cloudy cluster and the different available HPC interface things to come up with a sorry.
Good.
You're doing good.
All right. So the whole abstract is like we're gonna come up with a yeah, we're gonna assemble, we're gonna use a genome data that Nathan has and use a portion of that structure to create the original structure of the DNA. And so we're using red flower beetle. First, we were gonna use a cricket genome, but the cricket genome, due to some privacy or some for a reason, I don't know. For some reason, we couldn't use, and we're using our red flower beetle data. And so red flower beetle it's a pest that infests stored food grains, and a higher quality genome assembly could help scientists find better ways to reduce its economic impact. It is like this pest is like very damaging, like economic wise, like it damages food grains. So this our project will help will enhance like researchers to come up with a solution to to come up with a solution to like fabricate pesticides or like study the genome, the structure, and come up with a solution to fight or to eradicate the damage that this pest is gonna bring. And so we used we assemble high quality genome, which is 205 megabases from 30 billion bases, or the sequence risk using the Canoe assembler. And this requires a minimum of tens of GBs of memory and possibly thousands of CPU hours. And our data provider expects it to run days or weeks on an older cluster. And now we're using the cloudy cluster that Omnibond has provided us with. And that's it. And when we come to the cloud computing resources that we use, the compute nodes, we use the C5.18x large instance. It's a feature that it's like a processor, and parts of the application, like the Canoe, run on a single core. Like it needs a lot of processing cores. So we want to use like the fastest, fastest core. And so actually there are a lot of machines under the EC2 instances. We can there's a M, C, D, but we chose C because C is usually used for intensive calculation applications and computing application stuff. So the other thing I want to mention is that AWS cost scales linearly with the virtual CPU and memory. The Amazon charges us if we're using a different instance, they're gonna charge us a different amount. They have a rate per hour, so the hour changes or varies with the kind of instance that we are using. So for this, I don't actually remember off the top of my head, but
it was $3.06 per hour.
Yeah, so it was $3.06 per hour, but because we had a lot of money, we just a lot of credits.
And thank you to our sponsors here.
So Canoe needs big memory for the part of the application, and we don't exactly know how much of a memory it needs, so we're using the biggest. The other thing is the data storage. So we use the 3 terabyte OrangeFS on general purpose ST GB24 working data storage for file servers C4.2x large. And Canoe it's IO intensive, it reads and writes to files. So, and Amazon Elastic File System, home and software directories accessible from all NAS. The challenges that we run into or that we were facing were there are technical hiccups that I actually don't know what it is, but Brandon and his crew worked tirelessly to resolve. Shout out to Brandon. And default AWS EC2 instance limit, they had a limit and they didn't allow us to use anything, it was 0. So we had to, we had to contact them, and they actually partially gave. We requested for 20, but they provided us with 10. The progress that we have made so far, we use test data of E. coli bacteria, and the assembly took 21 minutes. And we are also running the original data, which is the red flower beetle data, and its assembly is partially complete. And before that, Canoe has 3 stages. The first stage is what was the first stage? Correction. Yeah, the first stage is correction. The second one is streaming, and the third one is assembly. So when we uploaded this PowerPoint slide, it was on the first stage, but after, like, when we got here, it is currently it finished the second stage, and now like it's on the third stage.
This is actually with about a little less than a quarter of the original data set, just for
Yeah,
to
indeed.
validate that,
Yeah.
that it could work.
So the future work, tune canoe parameters for better performance on C5.x large instances. So defaults don't use all memory and processors on each node, and it's useful for researchers who want to use Canoe on AWS. And we complete this red file beetle genome assembly. It's gonna like finish. We don't know in how much time, but it will soon end.
Yeah, probably not tonight.
No,
I mean, not with the whole data set, so that's where we're testing on a part of it. But at least we did run using the that E. coli data set, so at least we validated that the software works.
Cool. And that's it.
So, I did a quick demo part. It's not much of a demo, but
Does the
At
time
least to show
required
you.
go up exponentially with data set size?
so
You say what?
Does the time required to complete go up exponentially with data set size?
We're gonna actually.
the time is dependent on the genome size, the amount of input sequence, and the repetitiveness of the genome. So red flower beetle is relatively small. It's like 200 and, so you can see that. So, so it's about 205 megabases, I believe. We have about, I don't know honestly how repetitive it is, but just for comparison, a human or other mammalian genome using the software is supposed to take around 10,000 to 25,000 CPU hours to complete and require, I forget exactly how much data storage, but there's a little bit of documentation in the community guide with respect to that. So yeah, we really didn't know, there's no online calculator. That would be nice if somebody came up with one, at least not that I can. So this demo is just, okay, so right now, yeah, this is the second stage correction. So I'll just, to show what Samuel meant by opportunities for improving the efficiency of this on the C5 instances that we're running on. So right now it's currently using all of the nodes, but if we log into any one node, we can see, so right now, oh, okay, so it moved on. So this, I am not sure about, this is probably a C++ application. So just before I came up here, it was running Java and it was using 12 threads. It was hard coded using 12 threads and like 16 gigabytes of memory. And so for this particular instance, that's obviously not using all the resources that it has, since it has, I think 36 physical cores and 144 gigabytes of memory. So, but that's, you can kind of see how little actually, okay, so it looks like it might be in between stages here, but yeah, essentially, so the system is mostly idle at this point. So there are probably some opportunities to tune it so that it makes better use of the resources on an individual node.
How are you monitoring the usage across all the nodes? Are you manually logging in and doing top, or are you?
So this, well, this is a particular node, right? So with Cloudy Cluster, it appears that the default configuration is if you have a job running on a node, or maybe it's on every node in your virtual private cluster, then you can log into it with SSH by specifying the IP address. And that's listed here under the nodes. I suspect there's some entry in Etsy hosts for that. But yeah, you can just pick one and log in and then monitor what's going on in the
My question is mainly just like if you have a job that spans across let's say you're running 5 jobs and you want to do an average and say I have 10 jobs, they all run the same thing. I want to get sort of a nice little mean and standard deviation of how the resources are being used, something like that. Do you-
Right, yeah, so-
Do you get those type of stats across the?
With, I don't believe so because Slurm has accounting information disabled, I believe, by default on Cloudy Cluster, so we can't see. There is some information that's in these log files that Canoe emits, so we could, I guess, sort of manually parse that from the text files and reconstruct that, but yeah, as far as like how Canoe scales, if we fed it different amounts of the input data set, yeah, we were thinking about doing that originally. Try it on a small test set that's larger than see how it scales so that we can, get an estimate of how long the full data set would run, but time.
Yeah, you can do everything, yeah.
So I have to ask the Cloudy Cluster guys, because they're here. Do the Dustin job schedule actually phone home to a master dashboard or anything like that?
There's a dashboard page that reports like the CPU hours and the number of instances and everything, but there's not a job runtime. We do keep track of that in the database. We have, you can look at it in the database and how long the runs take on different instances. And we're working on pushing that towards a more dashboard page, but that hasn't, it's all there. We have all the information, it's just not being displayed at this point because we're still working on finishing up that user aspect of it. So we do have how long it runs on each type of instance and how many instances it ran and all the configurations. It's just not being all the way pushed up yet.
That sounds like a next hackathon project.
Cloudy Cluster Visual Analytics.
Yes. Yes. So it is there and it will be in a future version. It's just not fully pushed all the way up yet. All that is being saved, just not in a way that you can, if you go in the database, you can see it. You just can't see it from the user interface at this point.
Okay. That's good.
Very cool, guys. All right. And then there were two.
No, we stare them down with grit.
Okay, so does the winner go or not?
Okay.
Oh, wait, we're gonna put the, wait.
All right.
Rock, paper, scissors.
1, 2, 3,
Okay, so
go.
we
You don't know how to play rock.
No, he plays it really well.
Rock, paper.
Okay, hold up. We need to standardize this. It's on
Rock, paper, scissors, shoot.
Uh-oh.
Thank you.
I love the honorary royal way of moving on.
It's letting you know that I don't think he wins, but you know.
No,
Well, he does trade. You know.
I know.
One to control the computer, maybe two on the other side.
Back in my day.
All right, Mr. Worldwide. I'm assuming that Glorious Hedgehog is your GitHub.
Yeah.
Is that correct?
Yes.
Excellent. Well, nobody thought I was funny. I thought it was funny. I know.
Does anyone know which setting you want Windows on?
Extend, right?
I'm trying to get.
Yeah.
Usually just hit present and figures it out.
Yeah, I mean, yeah.
Yeah.
Like one that looks.
Yeah.
Well, yeah.
Because it doesn't have a lot.
You guys, you know,
I mean, I have.
Okay.
Yes.
Can I do that?
No. But if you pull just.
Oh, I see. Okay, never mind. Wait, what? Give me 1 second.
You can do extend.
I want to switch these. Okay, I want that full screen. And
That way.
He's ahead of the game.
Okay, I'm just gonna extend it.
Yeah, this is a dashboard.
Alright. Okay, we're now ready. Sorry for that. So, our project is called Web Page Translation using machine learning / AI. Yeah. So our motivation was to just mess around basically with machine learning models for translating one human language into another human language, like English to Spanish, vice versa. Ideally, you find some way to increase the accuracy, decrease training time, make some really huge advancement. But there were some obstacles, and we'll go into those. But we had a secondary goal, which went a lot better. We wanted to create a useful application with our newly trained model. And going down that road, we found some good results that I think you might like. So if you go to the next slide. We use TensorFlow and AWS to train the models. And as you heard from the chaos/order team, there is a problem with AWS. If you don't know about it, you have to request an increase in instance limits for most instances, definitely all the interesting ones. So we needed at least 8 GPUs to be able to train a good machine translation model. But we didn't realize that you had to request that until late last night. And we also didn't realize that it really helps a lot to just talk on the phone to someone until this morning. So we didn't have access to a GPU instance on AWS until, I don't know, 8 hours ago. So we didn't have a ton of time. But as Yoko will tell you, we started putting our time into this other project.
So yeah, the starting idea was to get the machine learning model trained in order to translate web pages. So in order to translate web pages, we have to fetch the HTML content of the web page. So in order to do this, we used Java and created a source code fetcher, translator, file extractor, and HTML parser tools. So that you can give the URL for your Java program, and that Java program can parse your HTML source code and do the translations by using machine learning. That was the beginning plan.
So in our original plan, we were planning on having a Python script to get the output from our machine learning model, feed it into our Java app, which the Java app would let the user select the language and the URL of a web page to be translated. We did get that second part working pretty well. And what it ended up being is just a pretty basic Java GUI app that lets you input a URL, target and source languages, and then outputs a translated HTML file.
So these are basically a summary of the obstacles. We did successfully train a English to Vietnamese machine learning model. That worked. So like technically the configuration to train these models was working. It was just a matter of computational time. We were able to train this particular model because it only had 2 layers. So it doesn't take super long to train a model with 2 layers. But if you want to be accurate, you need at least 4. And that takes a heck of a lot more time. So we couldn't improve on it or, train good, accurate models for different languages. And the other problem was just downloading the data sets. Because the data sets are just text. You would think, oh, that won't take that long, but it can take a while. It's a lot of text.
So yeah, we have to make a quick decision in order to use Google AI Translation API instead of machine learning, because as we can see in the next slide, we have two important advantage that this API gives us, because Google's API is a very thoroughly tested and very effective API. We can do API calls in a matter of milliseconds and get the translations right away, instead of waiting a machine learning model that takes maybe a couple of days to finish. And also, as we said yesterday, we were planning to translate between English and Amharic, but now using Google's API, we can translate to and from one of the hundreds of languages that Google's API provides you. So we have increased our flexibility and reliability by using this API instead of the machine learning model, and it turned out really well.
So, like I said before, our Java GUI lets you input a web page, target source languages, outputs a web page. But the fun thing about this was it actually will load all of the images, scripts, and CSS from the original web page, and it'll just translate. It'll basically seamlessly translate the text for you. But the rest of the web page is completely intact and fully functional.
We have a quick demo. This is our app, very tiny little GUI. And here's an English web page, right? But let's say we want to translate this into Amharic. We just put the link to the web page in the GUI, and then here are the language options. Leave it like that, and then click translate. And then you just wait as it processes all of the different English text on that page. And we'll open up the new web page.
And it's not only for English, Amharic. You can choose from one of the 100 languages for the source language, and you can also choose from one of the hundreds of languages provided by Google's API for your target language. So it's very flexible. You can deal with almost any language that's available.
This is just a quick summary of all the things we depended upon. AWS and TensorFlow, of course, aren't particularly important in the GUI app, but Maven, Java, translation is the guy.
Wait, don't go to the next page, you want to show that. All right, thank you.
Oh, wait.
That's the right order. Yeah. Oh, yeah, sure. So this GUI application that we made has, I believe, some useful applications because it's currently using the Google Translate API, but it's really easy to make it so it uses whatever machine translation model you want. So with enough computational time, we could finally train really interesting machine translation models ourselves. And then, there are ways of scoring these things with benchmarks to get a numerical comparison between their accuracy. But what if you just want to see what your model looks like in practice? All you would have to do is hook it up to the API in our app, and then you can take a web page that you visit every day, run it through the translator, and see just what it feels like. So I think that would be really cool for people who are developing the newest and the best machine translation models.
And another advantage we have from our projects was this was a side effect project. A side effect project and side effect advantage, because we didn't plan to have this advantage in the beginning, but we have a new Java tool that can parse HTML text. Like, has anyone used JSON before?
Wow, JSON.
It's a library that's available in Java, and if you give it an HTML source code, it will give you the body text as a single string. But our tool can give you the body text as a bunch of strings without changing the HTML structure, so that, as you can see here, you can modify the web page. For example, as we used here, you can do translations, or you can edit the body content of the web page as you want. And this will be very handy for developers who want to do web scraping and play with web page source content.
And finally, we just like to thank everyone, especially Omnibon, all the mentors who are very helpful, and we could not have done it without you.
Do we have any questions?
How did you guys handle the encoding of all the characters in different languages and all that kind of stuff?
You gonna cut it?
Okay.
Yeah. It just works. Yes.
How did you guys get the parsing to recognize when something is something you need to translate? Like, I'm guessing you're not translating like a header, like
Yeah.
for HTML text.
So apparently, I mean, you have to wait.
So whenever there's an HTML part of the code, it starts with a less than sign with an opening angle bracket. So you can keep a counter from that, and you can see the state of your counter to see whether or not you're in HTML code or in body text. Whenever you find a body text, you can grab that string and pass it to the Google Translate API, which will give you like the desired language, and you can put that back into your source code easily without having to do any much work using the tool. So it's very straightforward. Any other questions?
So, TensorFlow. Poor TensorFlow. No, if you had, let's say, a week to work on this, what would you have done differently? Or at this point, if you knew you had another 3 days ahead of you in order to work on this, what would you have done differently to maybe make the original model work?
Nothing. It really just was computational time. Like the data was not ready to be trained on at 2 p.m. today. It still wasn't done. So it's like, okay, well, definitely not going to be able to both train and attach a model to our GUI application in the next 2 hours. So
if you knew you had 3 more days, you would have gone for the training?
Yeah, if we had 3 more days, we would have trained different models. An attention model, a model with a different number of layers than Google has been trying, and different combinations of data sets, because there are a lot of things you can do, especially just with training on a single data set, and make sure your model really understands one language before you ask it to translate into another. There are a bunch of options there, but they all take computational time. And if we did have the computational time, then we do a comparison with this application and see how it works with web pages that people are familiar with.
What do you foresee to be the benefits of training your own model or using a model that like AutoML that lets you train your own? Do you foresee a benefit in translation, a benefit in translation in your specific use case since you're doing an additional manipulation around the language set? Would you, or would, because you can provide an additional context, do you expect additional benefit that way instead of just a generic translation API?
Yeah, that's a good question. I would say both of those could happen. I mean, the TensorFlow training, how it's set up right now, is automatically checking the blue scores as you train the models. So, if you're trying something and you find that you have a state-of-the-art blue score, that's something to take note of. But yeah, I think it also would be really good just to have this new benchmark that's not as rigorous as the other ones, but just lets you know, like, if this model is translating my web pages for me, what will it be like? So it's a different perspective.
I'm going to throw an extra hint on that. So you all had a unique resource on your team for a particular language set that you may want to throw in there. So you had a unique resource, hint, on your team that had a particular unique language that may help answer her question a little bit better.
We're trying to create, so the initial plan was to create our own machine learning model, and because I can speak another language, we're trying to get source text from my language in English and compare how that would work and compare if we can improve the existing models or not. But because we couldn't run that
machine learning model overnight as we planned. We only got it by 2 p.m. today. We were forced to use Google Translate API, but it's worked really well.
Okay.
So
It's cool.
sorry, does Google Translate not support your language?
It does. So the demo is shown in my panel.
Oh, it was?
Yeah.
Okay.
It supports hundreds of languages, so you can translate between from and to any language.
The reason I ask is because models tend to be trained with a higher degree of accuracy if they have a specific context. So you tend to, like a specific language in that kind of understanding. So the basic APIs that are provided by the cloud providers are really great in a broad context, but as you start to drill down into, looking at not just cats and dogs, but specific kinds of animals in a specific region of the world and variations between juvenile versus adult, there are other training sets you can use, and then you start to see additional benefit from them by training your own model. So it's a really cool example of pivoting to get a quick answer and the base level that's provided, and then a really interesting opportunity to build upon that and build even more sophistication with your own knowledge set as a team above and beyond that.
That area, the thing that you're talking about is called like domain adaptation. So you take a generic model and you adapt it to the domain you care about. So if you're really interested in it, if you want to like dive into doing stuff like that, I can actually do a pool of people who work on domain adaptation stuff. That's essentially what you do. You take a model that's good, you adapt it to the thing you care about. You just do like post like tuning all and then it's cool stuff.
So it's that old models used to be horrible back in the day. So the translations, like the indefinite articles, wrong context, wrong tenses, incorrect verb usage, it was nasty. And so going to other languages, you could add exactly what this young lady is actually saying, you can make it work the way it's supposed to. So when I say you have a unique resource, it truly is a unique resource. And our final group.
And no rock, paper, scissors.
Buy low, sell HPC. Okay.
All right. Give it a minute. There you go. Hi, everyone. So our team name is Buy Low, Sell High Performance Computing. And I'm Ted. This is Jack. This is Michael. And our project was effective project reviews on company stock prices.
So before I get into the technologies, I should give you a little bit of background on what the project was about. So basically what we wanted to do is look at the correlation between product reviews of a company and the company's stock price at that time. So to basically see if negative reviews correlated with a company's stock price dropping and how that sort of worked out. So to accomplish this, we used a number of things. First, we set up an EC2 instance that allowed us to do a little bit of computing and make sure that the data we were getting in is the type we wanted, and that, basically to do some initial processing. We used S3 to transfer our data and to store it. And EMR was used as our main way of evaluating the data, parsing it, cleaning it, getting into the right format. And through EMR, we used PySpark, which is basically a Python way of using Python with Spark, and Hadoop, which was on EMR as well. So in order to collect the data, basically we used an Amazon user review data set that is offered for free through one of their services. And we collected data from electronics and we focused specifically on one company, Lenovo, and looked at their review data for their products. We also collected data like daily closing price for stock tickers from Yahoo Finance Query. And an EC2 instance was originally collected to hold all of this data, but after we kind of decided that this data was indeed something we'd like to use, we put it on our EMR instance through transferring it through S3 buckets. So in order to process the data, we used EMR. We put these things into the Hadoop system, and we used PySpark to basically take the 3 million electronic product reviews we had in our S3 bucket and process them down to the 2,000-ish Lenovo product reviews that were of interest to us. We then basically wrote the data for these products to a CSV file, which was formatted specifically to help our regression model that we'll talk about in a second. And that's basically it for the data collection.
Okay, so to analyze the data, we're trying to think into the future rather than the present. So what we're actually doing is we're trying to take whatever data is available to somebody looking at the stock market and at reviews that are being generated at the time, and try to predict whether there's going to be an increase or decrease in the stock value at a subsequent time. So the way we did that is we got together a list of predictors that we thought would model the system. So we were looking at things like just the score of the review, 4 stars, 1 star. And things like, is it a verified purchaser who made the review, and multiplying that by the score to see if those reviews are a better predictor. And then also multiplying if it was a buying reviewer to see if that was correlating. We also actually had another variable that's not listed there. We also took into account how many reviews there were in our rolling average. So the way that we were keeping track of all this is we figured it's not going to be just one review predicting everything that happens. So what we did is for every day in our stock data, the stock price data that we had, we computed a rolling average of the last 30 days. The last 30 days when the stock market is open, we compute the average of all reviews posted in those days, and we use that as the predictor values that we are going to make a model based on. From there, we're just running a linear regression, trying to a least squares regression, trying to predict whether these predictors can give some insight into what the percent price change will be from that day to the next.
So we initially chose Lenovo. We mulled around a list of companies to choose, but basically we settled on Lenovo because their stock was not very volatile, so we could definitely see changes expressed in stock prices. And also they're a pretty specific focused company. They only work on electronics and consumer electronics for the most part. So on the left here, we have day over day fluctuation of the closing price for the month of August of 2015. And then on the right, we have the reviews for that month as well. They are normalized. We put a review of 3 stars or 2.5 stars at 0. And then, so anything below that is a very negative review. And above that is positive.
Okay, so this slide here shows you that our model did not perform especially well. Now, we can give you a lot of reasons why that might have happened, and none of them are conclusive, so I'd like to go into some of my favorites. One thing is that I don't think that we actually chose an appropriate range for the rolling average. I think that 30 days, which was kind of an arbitrary thing, we probably could have picked a different one that might have worked, and we didn't wind up trying out as many of them because we were, of course, debugging a bunch of code. And then another one is just, we're not sure to begin with that that stock traders actually care about reviewers and customers. I said it. So we went into this fully aware that there might just not be a correlation. It might be that the stock does what it wants and the reviewers say what they want. And another possibility is that we might have just straight up not had enough data. But I think that the way that our coefficients and our 95% confidence intervals look, which are pretty absurd, I'm not going to hide that. We've got a 95% confidence interval going from negative 4.09 times 10 to the 7 up to positive something times 10 to the 7th. That suggests there's probably something going on in the FIT program that we use. We're using we're using the OLS package from
SK Learning?
no, we started out with SK Learning. We actually switched to stats models. So we tried two. We got some wonky things both times.
So one of the issues we could definitely address is to get Lenovo product data, we just scraped for Lenovo, or we filtered all the products that had Lenovo in their product name. So ideally what we wanted to do was use this a ASIN number, which is a number every Amazon product has, and it can be traced back to a brand. But we have that number in our data, but unfortunately you kind of have to scrape Amazon's web pages, product pages to get the brand, because they didn't provide a way for us to do that. So that might violate terms of service, and they don't like that. So we didn't do that. So some other additions in the future, we have some code for sentiment analysis, and we have the text for reviews. So it'd be pretty easy to run sentiment analysis on text reviews to see if that is a stronger predictor for stock fluctuation than just, you know, 5-star and no text. We would also love to look at text reviews ratings and see the difference there. Finally, obviously, we can expand this to other companies as well, not just Lenovo. We thought that a car company would be good for this kind of thing because they do yearly releases and they're pretty big. So we could definitely see a notice difference there. So originally we were hoping to use professional reviews from a number of different review websites and scrape those and do sentiment analysis or scores based on those, but that's a lot of complex scraping and we didn't have time for that, unfortunately. So that's why we reverted kind of to the AWS data that we could find readily available. And so in the future, we would expand to that. And there's a lot of other data in our Amazon review data that we would like to process and see if that also has an effect on some sort of fluctuation. So thank you for having us. We enjoyed and we learned a lot.
Any questions?
I do. So Lenovo is primarily traded in Hong Kong dollars, and is only traded over the counter in the United States. Did you use the Hong Kong data or did you use the United States data?
We used the United States data, yeah.
Then probably a lot of what you were actually seeing is the exchange rate fluctuations and not actually Lenovo changes if you're looking at change between open and close. Yeah. If you look between opens, I bet you would see much larger changes in the price.
We did look at it between opens. That wasn't made very clear, but it was the fluctuation between opens.
Another thing that
but the exchange rate is definitely going to be a factor there.
So another thing we did consider also was the percent, because we're considering the percent change, and we're hoping that will wash out a lot of longer term issues. Like for instance, you know, if you're jumping $10 in a day in 2018, but we're jumping $2 in a day in 1998, then maybe that was just because that's a similar percentage of the stock price. So we're hoping that things like that wash out. I realize that doesn't.
I don't think that's fine. Unfortunately, it does not work like that, and you first have to detrend your data, because if you look at two completely uncorrelated charts that both go up, they look. Regression will show you that they are related, and they are not.
Right.
You first have to detrend it so that it is on a straight line, which I'm sure you found in your research. So that's another idea for future work.
Okay. So I'm curious, so you chose Lenovo. Who else did you consider? Apple?
Basically, it was a lot of consumer electronics companies. Part of the original qualifications was we wanted to have something with a high volume of professional and consumer reviews, because the idea would be to compare the two and see which one, if either, have an effect. So electronics is a good area for that, because you've got the personal reviews coming from people on sites like Amazon. We've also got professional reviews for people that are in the industry and more interested in it. The other one we considered was vehicles, but that kind of is a little bit less on the consumer side and a little more on maybe perhaps the professional side. Yeah.
So one more question, so I'll follow up to that, so you mentioned arbitrarily it was 30 days,
Yes.
right? So how did you, I know it was arbitrarily, but what were you thinking as far as, okay, I have this product out on the market, and for the next 30 days, or for the previous 30 days, however you choose to look at it, do you think that 6 months before would affect the present day value, or did you give any thought to that, or how do you?
That's something
unpack
we'd
that a
like to
little
look at, but like for consumer electronics, you frequently have like reviewers that get the product before everyone else. So that's something we're trying to take into effect.
Yeah, and I think that's good, especially with a product to market and how fast it goes, and they build as you order.
Yeah.
That was the right choice. Just want to hear you unpack that.
Did you consider doing any kind of filtering of the reviews themselves?
Yes, we did consider it, we did not do it.
I mean, in what sense do you mean filtering?
Like, if you go on Amazon and you look at the reviews, you will often find that some of the, especially the lower rated reviews, are things like UPS damaged it, which really don't have anything to do with the product.
Yeah, so you're definitely right about that, but part of the thing that the regression model took into account was the helpfulness score of the thing. So basically, if somebody said UPS, product derived damage from UPS, that's not a very helpful review. And that's going to be weighted less than, I got this product, it was certified authentic, and in 30 days it shut down. That's going to be more helpful because, and that was given a much bigger weighting by our system.
Yeah.
So that was a thing we did take into account, at least to a simple extent.
Okay, thank you. Great.
All right, guys, I am mid-type and putting a poll online. So if you all, while our judges, Amon, go make their very difficult decisions of the rank of the presentations. Y'all take a moment to kind of get to know the students. We will be right back.
I'm gonna send you guys a link to the survey for Alex that was here. He flew back to Estonia tonight, he's flying back. But if you guys can please fill out that survey for him so he can look at all that and analyze the data of the HAB and what we can improve on, what we need to change, or what we need to work on, or what we can advise to you guys to help, things get along, or, code, or whatever we can offer to you. So if you guys don't mind, I'll send you that right now while we're trying to judge everything, and if you could just fill out the survey real quick. We appreciate it.
And we will be right back. So guests, if y'all wouldn't mind, I know there are drinks down there. Do you need to give them fresh drink tickets, Amy? Or do y'all want to wait until the winners, which is
right here. Yeah, not your pocket.
Oh, yes, we do have.
So we can do that, and if you guys want a soda or a drink or whatever, we can do that downstairs.
Yes, no, so.
Yeah.